In this video lecture, we are going to have discussion on the electric charge. So basically, what is an electric charge? Electric charge can be best understood in terms of the effect, they produced. And the electric charges are basically the physical properties or the physical characteristics of subatomic particles. So by subatomic particles, we means electrons, and protons. And by physical characteristics or physical properties, we mean that electric charges are basically the physical characteristics or properties of matter. So physical properties of matter are those which can be measured or observed without changing the chemical nature of a matter or a substance. So in case of an electric charge, we can say that we can measure the electric charge without changing the chemical nature of this electric charge. So basically, we can say that electric charges are the physical characteristics or the physical properties of matter. But how do we observe the nature of this electric charge? Now, if we place this electric charge in any electric field or electromagnetic field, then this electric charge will experience a force. So we can say that the electric charge is the physical nature or the physical properties of matter. And we can also say that electric charges is an intrinsic property of matter. So basically, what is an intrinsic property? So intrinsic property of matter is the last property of matter, which is inheritance to any substance. And basically, this electric charge is the intrinsic property of matter. And this electric charge is inheritance to this subatomic particles, electrons and protons. So just like a mass of a body, mass is also the intrinsic property of matter, because the mass of any substance will not change if the substance is located on the surface of the earth or at the surface of the moon. The mass of the body will be constant because it is the intrinsic property of that substance. But the weight of a body is not the intrinsic property of matter or a substance, because it is changes from one place to the other. So just like a mass, an electric charge is also an intrinsic property of matter. Now let's move towards a second point, which states that the symbol for the representation of a charge is Q and the unit of a charge is Coulomb. So the symbol which we use to represent a charge is Q. The unit which we use to measure an electric charge is Coulomb. After the extant Coulomb, we can call the unit of electric charge as a Coulomb. Now, one of the first phenomena observed in the study of electric charge was that there are two kinds of charges basically. The one is positive charge and the other one is a negative charge. And the positive charge is observed on proton, while the negative charge is observed on electron. And the fundamental charge which is present on either on these two particles is equals to 1.6 multiplies 10 raised to the power minus 19 Coulomb. This is basically the fundamental charge. Fundamental charge on any of these particles. So the charge on electron will be negative. The charge on electron will be equals to minus 1.6 multiplies 10 raised to the power minus 19 Coulomb. While the charge on proton will be positive. E plus will be equals to plus 1.6 multiplies 10 raised to the power minus 19 Coulomb. So this negative sign represents that the charge on electron is negative. Or sometimes we can call this negative sign as the electronic charge. Now let's move towards another point, which is the important point, which states that the charges are quantized in nature. So what do we mean by a quantization of charges? So by quantization is basically we means that a substance or a particle which present in discrete form, not in fractional form. So by discrete form, we means that which present in the form of a whole numbers, or we can simply say that the which present in the integer form. in integer form. So basically the electric charge for these subatomic particles are present in integer form, and we can say that the electric charge Q will be equals to the integral multiple of this fundamental charge. So where this n is basically the integral multiple, which is equals to plus minus 1, plus minus 2, plus minus 3, up to so on. So by this positive sign, we means that if we have an extent of positive charges on a specific substance, then that substance carries a positive charge, and by negative charge we means that if we have an excess of electrons on that substance, then the net charge on that substance will be negative. So the electric charges are always available in the integral multiple of a fundamental charge. It is not be available in fractional form like 1 divided by 2e or 2 divided by 3e. It is not be available in the form of fraction. Now let's take an example to understand this quantization of charges. Which states that how many electrons are required to form 1 coulomb of charge. So the requirement here is the number of electron which are required to form 1 coulomb of charge. So the charge is given to us, which is 1 coulomb. So how many electrons will be required to form 1 coulomb of charge? And we know that the elementary charge is equals to 1.6 multiplies 10 raised to the power minus 19 coulomb. Now to find out n, we can use this equation. So this equation states that Q is equals to Ne. So n from this equation will be equals to Q divided by E. So n is equals to Q is already we have, which is 1 coulomb, divided by, and the electric charge on the fundamental particles will be equals to 1.6 multiplies 10 raised to the power minus 19 coulomb. So coulomb will cancel coulomb. So if you use your calculator, then you will get 6.25 multiplies 10 raised to the power 18 electrons. So 6.25 multiplies 10 raised to the power 18 electrons are required to form 1 coulomb of charge, which are very large in numbers. A most significant effect of electric charge is that it can produce a force. So when we place an electric charge in an electric field or electromagnetic field, it experiences a force or it produces a force. Now before going towards the explanation of this point, so as we know that two charges with the same sign are repel each other with a force called a repulsive force. And two charges with the opposite signs are attract each other with a force called attractive force. Now to find out the force of attraction or repulsion between two charged particles, a Coulomb defined a law which is called the Coulomb Law, which states that the force of attraction or repulsion between any two electric charges will be directly proportional to the product between these two charges and inversely related to the square of the distance between these two electric charges. So if we increase the distance between these two charges, the force of attraction or repulsion will be decreases. Now if we increase the amount of electric charges, then the force of attraction or repulsion will be increases. Now after combining these two relations, we get F is directly related to Q1 Q2 divided by D square. Now to remove this sign of proportionality, we include some constant here, which is K in this case Q1 Q2 divided by D square, where this K is the constant of proportionality which depends upon, and this K is basically the constant of proportionality which depends upon the medium used between these two charges. and the value of this proportionality constant is equals to 9 multiplies 10 raised to the power 9 Newton meter square per Coulomb square. Now let's move towards another property or another point, which is the most important point about the electric charge, which states that for any isolated system the charges can neither be created nor destroyed. So by any isolated system we mean that a lonely system which do not depend upon the outside environment. And this point basically states the law of conservation of electric charges. Law of conservation of electric charges. Now to understand this point in a more brief way, if we have an isolated system like this, and here we have three substances present inside this isolated system, and the charge on this substance is, let's say, 2 Coulomb plus 2 Coulomb, and the charge on this substance is, let's say, minus 4 Coulomb, and the charge on this substance is, let's say, 10 Coulomb plus 10 Coulomb. Now if we shuffle this system, and after shuffling we get the same system with such kind of charges. Plus 5 Coulomb of charge is present on this substance, minus 7 Coulomb of charge is present on this substance. So if you are asked to find out how many charge will be present on this substance, so according to the law of conservation of energy, which states that for any isolated system the charges can neither be created nor destroyed, which means that the charges will be constant before the shuffling and after the shuffling. So we can easily say that if, let's say, the charge on this substance is Q1 and the charge on this substance is Q2 plus the charge on this third substance is Q3, will be equals to the charge on this substance, let's say Q1 dash, plus the charge on this substance Q2 dash, plus the charge on this third substance, which is Q3 dash. So Q1, Q2 and Q3 we already have, which is, so Q1 is plus 2 Coulomb plus Q2 is minus 4 Coulomb plus Q3 is 10 Coulomb is equals to Q1 dash is 5 Coulomb plus Q2 dash is minus 7 Coulomb plus, and Q3 is the unknown which we will be finding. Now after calculating this you will get 8 is equals to minus 2 plus Q3 dash. So Q3 dash from this equation will be equals to 10 Coulomb. So the charge on this unknown substance Q3 dash will be equals to 10 Coulomb. Now if you take the sum of these charges present in this isolated system after the shuffling, and if you take the sum of these substances which is before the shuffling, then you will get the same answer. So it's all about the conservation of charges. So it's all for today's presentation. If you have any doubt, ask in the comment section. In the upcoming presentation we'll be talking about the electric field. So see you in the next one.